Okay, so on section 8, we're going to be taking a piecewise function like we had in the last one, and we're going to be changing it to a graph. Okay, so um, let's dive right in. A couple things before we start graphing things, just to kind of think about the picture of what we're going to be doing. For instance, on the very first one, if you're writing this in interval notation, which is probably smart, you would be, ooh, I don't want that. I want to scribble. I want to go from negative infinity. Why is it drawing such poorly? Okay, all the way to negative 3. Now, because there's no equal sign, that would be open. On the next one, we have closed, negative 3, comma 4, open. And on the next one, closed 4, comma infinity. And you can never put a parenthesis or a bracket on infinity or negative infinity. Okay, so what are those pictures going to look like? Just as just to kind of remind us, that would be open circle, arrow left. That would be a closed circle over to an open circle, and a closed circle, arrow right. Okay, so that's the basics of the pictures of what we're going to do. How do I figure out how to draw them? Because you know they're going to have different slopes like the ones in the last lesson. Well, I would suggest that we start with making tables. So we're going to make a little XY chart. And according to the information, I'm going to start with negative 3. And then I want to pick something that's in the interval. Of course, it has to be smaller than negative 3. So I'm going to pick negative 4. Okay. Well, how about the middle one? Okay, we're going to make a chart for that one too. Very, very simple, but always, always, always pick the values that if they give me both of the values, then use them. And this one's pretty simple, right? It's just plain old 6. So we have a 6 there and a 6 there. So that's I don't even have to do any calculations on that. Okay, and the last one we're going to make an XY chart for is this last line. We're starting with 4 because that's what they tell me to start with, and then we want something bigger than that. Now, because you are multiplying by a half or a negative 1/2, I'm going to pick an even number like 6. I can pick 5 if I want, but it's going to give me a decimal, and if I just want to avoid the whole decimal thing and just go with integers, then you would do that. So if I go back to the original one, all right, let me just get rid of some of these lines so it's a little easier to look at. So if we plug in values into this, like the negative 3 and the negative 4, so the negative 3 plus 2, that's negative 1, and negative 4 plus 2 is negative 2. All right, we've already got the middle one done, and so now it's time to go to this one, and we plug in 4. Negative 1/2 times 4 is negative 2, and negative 2 minus 2 would be negative 4. All I'm doing is plugging it in. You can use a calculator if it's not something off the top of your head that it's easy for you. Just plug it in, take that calculator, negative 1/2. Plug in a 4, subtract 2. That's how we got this value. If I plug in a 6, I'm going to get negative 5. Now, how's this going to look when I go to graph it? Well, so the negative 3, negative 1, that is, according to this information right here, that's going to be an open circle. The negative 4, negative 2 is a closed circle, and so we know that that goes to the, oh, I didn't draw that right. It goes down like this. There we go. So open circle, arrow left. If I go to the next one, negative 3, 6, negative 3, 6, closed dot on the left, and positive 4, 6, open dot on the right, and a line in between. You know you only need 2 points to graph a line. when we get to the parabola here in a minute, parabola takes at least 3 points. But for the lines, which are fantastic test questions, by the way, and now I can go to the last line, the 4, -4, 4, -4, we know that's a solid dot, and 6, -5, that's a solid dot also with an arrow. Oops, missed. Man, I'm not doing well here. Something like that. So there's our slope. Probably should use the line tool to make something look nice, but I was just trying to do something quickly. But that's the picture of what we want. Let's do more of these just to practice. Okay, so let's start before we get to the graphing. We've got negative infinity to -2 parenthesis. Then we've got bracket -2, comma 3, also bracket, because it's equal. And then lastly, parenthesis 3, comma infinity. Sorry, I guess I should have zoomed in a little bit to make it easier to write. So hopefully you follow the logic there. And now we can start making our tables. So for the first one, I'm going to make my XY chart. He does not want to write very well tonight. Let's see, we always start with the one they give me, which is -2, and then we want something smaller than -2, so -3. On the middle one there, we're gonna, they give me both -2 and +3, so if they give you the values, use them. Don't argue. Just use them. Oops, I forgot to put a parenthesis there. On the last one, they start with 3, and then you want something bigger than 3, which is 4. But this is the super boring one because, come on, give me a different color. Because we know that they're going to both be -3s, because that's the flat, that's going to be the constant line right there on that one. So now we could go back and plug things in, for instance, plug in this table into this one. -2, so the opposite of -2, come on, draw for me. The opposite of -2 minus 4. So that would be 2 minus 4, which is -2. And then if I change that to a -3, the opposite of -3 is 3. 3 minus 4 would be -1. And now I can take these, plugging them into here. 2 times -2, that's -4 plus 1 is -3. And plugging in 3, 2 times 3 is 6. 6 plus 1 is 7. Okay, so now that I've got my different tables, we can think about, we should probably also kind of understand what these things are going to look like. So that's going to be an open circle arrow left. This is going to be closed on both ends. And this is going to be an open circle arrow right. So just to kind of give us the idea of what our shapes are going to look like, we can come back over here and -2, -2. That's going to be my open circle. Wow, not doing well. -3, -1 is a closed circle, and that would be arrow left. So open circle, arrow left. On the middle one, we've got -2, -3. Oh, that's... So maybe I should zoom in here and do a better job of drawing my open dot there, because right underneath it is a closed dot at -2, -3. And then also we need a 3, 7, so way up here. And so we are going to be doing something like that. Man, formative, why aren't you drawing very well? And 3, negative 3. 3, negative 3. That's going to be back to that open circle. 3, negative 3. And then 4, negative 3. Remember, this is the flat line part right here. So these look like they might connect, but they don't. They don't connect at all. Okay, so this is a more complicated one right here. You've got a line, you've got a parabola, you've got an absolute value function. All right, so let's see here. We got bracket, -9 to -3, bracket, open, -3 to 3, open, and 3 is closed, and 8 is closed also. So, back to this one where you're just doing 2 coordinates. I would suggest that we use the endpoints, -9 and -3. Okay? So, -9, when I plug that in, 2/3 times -9 plus 3. That's going to be -6 plus 3, which is -3. Okay. And if I plug in a -3, that's going to be a -1 times 2 is -2 plus 3, which is a 1. Let me just double check that. Yep. -3, -6 plus 3. Yep. Okay. All right. Now, the next one is, as we talked about a few minutes ago, a parabola. Okay. Now we can tell that that parabola has been shifted down 1 unit. And I always told you to use the values that they gave me. I'm going to pick a number in between and see if that's enough to kind of get me the idea. Now, to be truthful, since there's more space in between, I probably should extend that table down and do like -1, 0, 1, and 3. Maybe give a few different values, okay? Maybe 5 numbers. That's obviously going to be better than 3. And since I have the space and it's going to be pretty reasonable, I might as well do it. So if I plug those in, like if I plug in a 3, the value at the bottom, that would be 3 squared minus 1 is 8. If I plug in a +1, that would be 0. If I plug in a 0, I get -1. If I plug in a -1, now be careful when I say plug in a -1, you're squaring it and subtracting 1. That gives me 0. Oh, look, these two match. And then if I plug in a -3, square it, and subtract 1, I get 8. Oh, look, those match. So, the last one, I wonder if I could do the last one without having to make a table. Let's see. So, let's do the first one. Okay. So, the first one, oh, that's going to be closed on both ends. Like closed, closed. The next one's going to be open, open. And the last one's going to be closed, closed. Okay. So using the line in those coordinates on the left, -9, -3, closed. Okay. -3, +1, closed. Draw the line. Okay, so that's a line. Next one's a parabola, right? So -3, 8, open. -1, 0. 0, negative 1. 1, 0. And back to 3, 8, open. And so you can see we have a parabola that's been shifted down 1 unit. Okay? Now we have the last one, which is the absolute value function from 3 to 8. Now, truthfully, I probably need to at least get myself started with the 3 and the 8. But remember, there's going to be other stuff in between, so maybe I have to put in more values. This has been moved 5 units to the right, right? So opposite, let's just analyze this part and see if that makes sense. It's 5 right. It's 4 down. And it has been reflected over the x-axis. So we know it's going to open down because that's changing the y value. Now, if 5 is in the middle, okay, and 4 down, 5 is in the middle, and 4 down, so we know it opens down. Well, it would make sense if I plug in 3. What is the opposite of 3? Okay, minus 4. So let's see. In the absolute value bars, you got negative 2, but the absolute value would make it positive 2. And then when you multiply that by negative 1, that would make negative 2. Minus 4 would make negative 6. Let's see. Does that make sense? Over 3 down 6? Well, yes, it does. So we've got to there. And then it's changing directions. So, whoa, not like that. What happens when I plug in an 8? 8 minus 5 is 3. Absolute value of 3 is 3. Negative 1 in the front makes negative 3, negative 3. So that's, whoa, negative. Stop doing that. Negative 7. Scribble. Negative 7. And let's see if that makes sense. 8 over 7 down. Yep, it does make sense. All right. Was that one a little bit more complicated? Of course it was. I don't necessarily think that would be a fantastic one for a test. For you to start with the equations and have to graph it might be a little bit of a stretch. Okay, let's see what's next. Okay, so write a rule for an absolute value function. So they want me to write this as a piecewise defined function. Now, I think it would be smart if we did one algebraic thing. What if we took the 6 and we factored it out? Now, what does that mean? Well, when you're factoring, you're doing division, okay? So I literally pulled the 6 out. Now, it's still inside the absolute value bars. Don't get me wrong there. Still inside the absolute value bars. I'm just pulling out that 6. Now, why am I doing that? So you can see that we have left 3. Left 3. Which makes a whole lot of sense why this graph is the way it is, right? Because they put negative 3 in the, kind of more in the middle. Now, did it go up or down? No, it did not go up or down. So it literally is going to be starting right here at negative 3, 0. They did do a horizontal shrink. Horizontal shrink, right? Because we said that changes on x were always backwards. So that would be a horizontal shrink. Man, it is just not. By 1 over 6. By 1 over 6. So it's coming together. It's really, really going to be shrinking in, real tight, right? You're pushing all the values together towards -3. So, for instance, something that was 6 units away, like -9, 6, used to be over here, but when we shrink it in, it's sitting right here. And of course, you got another one right there. So we've got a really skinny tall one. That's kind of the idea of what we've got going on here. Okay, they did a horizontal shrink. Now, how can I define that with piecewise function? All right, let me get rid of some of this. Give myself some space. Because I've got two functions here. Well, one of them looks exactly like the original one. Okay? If you were to take a look at this part of the graph, the right side only, that is 6x plus 18. Now, what part is it? Okay, well, that would be, I guess you could say from -3 to positive infinity. Now, you're probably going to ask me, why in the world would you include this at -3? I mean, how do I know if it goes with the right side or the left side? I don't know that, okay? This was a choice, okay? And I wouldn't fault you either way if you put it in the one or the other, okay? So now we can go to the other part right here, this part over here. Well, guess what? It's got the opposite slope. Basically, it's the opposite of 6x plus 18. Well, is there a better way to say that? Sure there is. What if I distributed that negative and made it -6 minus 18? And then I would say negative infinity, column 1, -3. I can't include the -3 in both, so you're going to have to make a choice. Are you going to put the -3 in on one side, or are you going to put it on the other? It really does not matter to me. You're not going to lose credit either way, so take your favorite pick, which one you want. But this is an absolute value function. So the moral of the story is the first one looks like the inside. The second one looks exactly the opposite. I mean, literally that's it, folks. Nothing terribly, awesomely difficult about it. So rewrite each as a piecewise function. All right, so y equals here to here. First one looks exactly like the one on the inside. Second one looks like the exact opposite. Okay? Straightforward, pretty easy. However, what's the middle of this? This is where that idea of pulling out the, in this case, the -5 and seeing what's left inside, and that would be x plus 2. And so you want to be able to look at that and say, oh, okay, so that's left 2. Man, why are you doing such a poor job of writing tonight? Formative. Left 2. It looks like I don't know how to write stop. Maybe I should just try my finger and see if that works better. So -2 would be in the middle of my table. And so, if you are thinking about this, it's been shifted. Let's see here. We've got a reflection across the y-axis. Doesn't make a big difference. It's been horizontally shrunk by 1/5. and it's been shifted to the left too. So truthfully, it's going to look something like this. Tall, skinny, slopes of 5 and -5. So the one that has a +5, that would be the +5 one would be the one on the right. Okay? And so since we've got -2 right there, that would be my -2 to infinity. And the other one would be the other side. That would be -infinity to -2. Now remember I said you get to pick. So if you want the bracket to be here and the parenthesis to be there, I don't care. Or if you switch it up, it's got to be on one of them, but it can't be on both. All right, next one. Now picture-wise, we know that this thing has been reflected over the x-axis and it's been moved up 3. So, we've got something like this going on. No left and right shift. So let's see here. We know we've got 2 parts to this graph, and it's breaking apart at 0. So we've got one side that goes from -infinity to 0, and you can put the bracket there, or you can put it on the next part. Doesn't matter to me which one it goes on. Let's see here. What else? So one of these equations looks like the original one, right? -x plus 3. That would be, come on, give me something different. The -x plus 3, that's the one on the right here. Because it's got a slope of -1 and a y-intercept of 3. Ooh, now let's see here. Something's different here. This side over here is not the complete opposite, is it? That's got a positive slope and a +3. Ooh, I might have to rethink this. Okay, I figured out the difference on how to explain this. So, the difference between the two examples that you started with, all the changes were on the inside of the absolute value bars. And in that case, you do have opposites, complete opposites. But on this last one, the only part that's opposite is what's on the inside. What's on the inside is opposite. Well, as you can see, one of them is +x and one of them is -x. So the part on the inside is opposite. But the part on the outside, the +3, is exactly the same. Now, you might say, well, what do you mean by the part on the... So, the part on the inside, for one, is x with a negative on the outside, and then I went with -x with a negative on the outside. Well, what happens to this one? Isn't this the one that changes into positive? So it's the opposite of what's in the parentheses, or I'm sorry, opposite of what's in the absolute value bars. But then the other things on the outside, they stay the same. Now that might seem a little bit confusing, okay? But if I back the truck up and try that again, all right, so one of them starts out with x, and then the things on the outside are exactly the same. But if I change this one to -x, because that's the part on the inside, and then you still have the negative there, and you still have the +3, well, what does this turn into? That's where that +x is coming from. So the part on the inside of the absolute value bars changes to the opposite. And then you've got the stuff on the outside that finishes off the equation. I do think we will probably have to practice that more. Okay, a step function is something that changes in incremental steps. So, as you can see, you pay one price from 0 to 2 pounds, you pay a different price from 2 to 4 pounds, you pay a different price from 4 to 6 pounds, you pay a different price from 6 to 8 pounds. Now notice every one of those is open, like 0, 2, closed. Open, no, not open 0, open 2, 4, closed, okay? Each one of them is open on the left and closed on the right. So every time we do this, we're going to be open on the left, closed on the right, okay? So from 0 to 2, we're at $5. Open on the left, closed on the right. We pay $5 shipping. Anything that's inside that range from 0 to 2 pounds pays the same price, $5. Now from 2 to 4, we pay $8. So from 2 to 4, open, closed. Who the heck made this scale? Woo, man. So there's 10. There's 12. There's 14. Okay. 4 to 6 is 11. So open, closed. 6 to 8, open, closed. Get that right. Close enough. That's called a step function. Now remember, domain, smash it all onto the x-axis. If I smash everything onto the x-axis, I'm starting at 0, open, because obviously nobody's going to bring a package that weighs nothing. Okay, and it goes up to 8 pounds, closed. Now what's the range? Now the range, don't tell me 5 to 14. That's not true. We have 5, 8, 11, and 14. So we literally want a set of numbers 5, 8, 11, and 14. Now you can see I'm using a brace. I do the best I can at drawing my braces. Okay, so only those values, 5, 8, 11, and 14. What are the maximum and minimum values of the function? Now, I need you to understand something. Maximum and minimum are y values. The maximum is 14. The minimum is 5. Okay, these are y values. Now we can say, and it's not exactly a good example in this case, we can say where they are. In other words, what x value causes that. In this case, it's a whole bunch of stuff. A whole bunch of values cause that. But when we talk about maximums and minimums, you need to understand we're specifically talking about y values. Doesn't matter what graph we're talking about, we're looking for y values when we say max and min. Okay, I think that's enough for today's lesson.